Welcome everyone to another episode where we delve into geodesy and distinguished geodesists in the world. My name is Mehdi Eshaq, and today we have the privilege of sitting down with Professor Martin Vermeer from Aalto University in Finland. With a distinguished career spanning several decades, Professor Martin Vermeer has significant contributions to physical geodesy, GNSS, deformation monitoring, and also navigation. Please join us as we explore his career, insights, and how his research has affected our knowledge in geodesy. Thank you very much, Martin, that you accepted my invitation for this discussion.
Yes, it's my pleasure, and I was rather happy that you invited me for this because I think it's an important matter. And I must say that during my own career, I may have neglected a bit to advertise for geodesy. So yeah.
Oh, thank you very much. Please, Martin, tell us a little bit more about yourself and your journey in geodesy, and what was the
Mhm.
key motivation that kept you in the subject?
Well, that's actually an interesting story because I was born in in the Netherlands, and I went to school also in the Netherlands, and I had always this idea that I wanted to go into science, exact sciences, and at that time there was the space project Apollo and so on, and it was, I mean, a very interesting time for science in general, and so I went to study physics, just the obvious choice, default if you like, and so in actually that study, I switched to geodesy because I also had at the same time I was active in Moonwatch, an organization for observing artificial satellites and determining the orbits of artificial satellites using very simple equipment like binoculars and stopwatches and radio time signal and so on. And I did that for a while, and I heard in connection with that work, which I did as an amateur, I heard that uh, actually we were requested as observers, we were requested to observe a certain satellite that also people in Delft were observing using a big camera, huge telescope actually, which was used as a camera. And they needed observations from us in order to support that somehow. I don't remember the details, but that's how I found out that, hey, there are people working with space in Delft. And those were the geodesists in Delft. And that's how I found out. And then uh, actually the study in Utrecht in physics, which I was at that moment uh, doing, it didn't go so well. And I decided, okay, let's switch. And so I applied to Delft and I started there as a student. And took me 6 years. The nominal time was 5 years. It took me 6 years to graduate as a geodetic engineer. That was an option then in Delft. It's unfortunately it doesn't exist anymore there. So the world has changed.
I think it was the time that Professor Borda was there. Am I right?
Yes, yes, he lectured us, and Professor Aardom, actually the space geodesy professor, he was very supportive.
Okay.
And you know that the Delft University of Technology, as it is now called, then it was the Delft Technische Hogeschool, the high school of technology. And they had a space observatory in Kootwijk in the east of the country. And that's actually where this camera was located that they used. And they were also building, or they had already at that moment, a satellite laser.
Okay,
And there was
wonderful.
other equipment too. So I wrote my engineer's thesis, if you like, which is engineer's degree of engineer is similar to a master's degree in other countries. So I wrote a thesis as at the end of the study on a subject related to satellite tracking in Kootwijk. That was actually quite interesting. It had to do with the use of the Kalman filter for predicting the satellite orbit, which has its own problems and difficulties.
During your career that you have done for several decades, what changes have you observed? So, what has happened inside the geology during these years for you?
Mm. Yeah, well, the two big changes, well, many big changes actually, but two main changes, and I think the most consequential is, of course, that we nowadays have satellite positioning, real-time satellite positioning.
Mm.
First, it was first it was GPS, but before that, you may remember, we also had the Doppler technique,
Yeah,
which
transit
wasn't
system. Yeah, yeah,
it
transit
wasn't
system. Yeah.
the transit system, which wasn't
Yes, yes.
actually quite real time, but it was
Yeah,
used
yeah.
for a while, and you could, if you were prepared to measure on a location for say a day or several days, you could get the position plus minus 1 meter or so. So that
It's
was, and
correct.
that was a geocentric position. That was,
Yeah,
that was not in a local frame, but it was in the global frame.
yeah,
And that's how
yeah.
it started. And then came GPS. And then
Mm.
now we have GLONASS and we have Galileo, we have Beidou, we're probably going to have more over the course of time because every country wants to build its own system now, which is possible. Even the SpaceX system, whatever it's called, this um, what was the name now? Starlink. Even it could be converted to a global positioning system.
Yeah,
And
yeah,
of
yeah.
course, it has lots more satellites, which has advantages and disadvantages. But
So I
so
can
so
say
the
that.
breakthrough of global real time, that's the number one.
Mhm.
The breakthrough of global real time satellite positioning. Uh,
Yeah.
the second one is, of course, what we have seen, the satellite gravity missions.
Okay.
And they're similarly revolutionary, but in a very different way. Not for spatial positioning, X, Y, Z, but for H, the vertical component. That's what is revolutionized by these gravity missions.
Hmm.
So
Hmm.
that's where we are now. Nothing of that existed back in the days, but now it does.
That's wonderful. Wonderful. Do you think that people, ordinary people, can understand the importance of these things? How can you
I'm not
explain this
sure.
to
They
people?
use they use GPS, of course, in their car and but even as pedestrians. And they think, okay, GPS is nice. It allows us to navigate. It allows us to find places and go places. But of course, it's not only GPS. It only works for navigation if you also have precise maps. And somebody
Mm.
makes those maps. And those
Exactly.
maps are not just pretty pictures. They are maps. They are
Yeah.
geometrically correct. They are geometrically accurate. And there are people that make sure that they are that they are geometrically correct and geometrically accurate. And we call those people geodesists. That's what we do. That's one
Yes.
one example of the practical use of
Yeah.
geodesy.
When we say to people geodesy, they immediately say geophysics, geology. No, geodesy. We look at the earth with
But
geometric eyes, but they do
yeah,
not realize what
yes,
does it mean. Yeah, yeah,
that's true. That's true. But
yes,
but there is of course a close link to geodesy and geophysics. That's also true.
yeah, yeah,
When you study
yeah,
the Earth as a physical system, I mean, there is a geometric part of that.
yeah, 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 absolutely,
And
absolutely.
that's actually, for instance, the location of sea level, tracking the location of sea level is essentially a geodetic problem, but
Yeah,
it's also great geophysics because there
yeah.
are
Well,
there are geophysical causes of what makes sea levels change.
I remember actually it was a discussion somewhere that one guy, when I was actually complaining on social media why geodesy is not that much get attention, and you see geodesy
Yeah.
just as a total station and GPS. So somebody wrote to me, okay, what else is it? What else is it?
hmm Yeah.
So,
Well, those
oh,
total stations are still very much used. You see them everywhere on building sites, and
yeah,
nowadays they sometimes have a GPS antenna on top.
yeah, 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 exactly,
So yeah.
exactly. So you have done a lot, Martin, in your life in geodesy. At least I know that you around 20 years. I have read your articles and I am rather familiar with you. But which one of these projects and the things that you have done so far you like more and you think that it will represent you actually?
Yeah, that's a good question, actually. It actually, what I really like doing is modeling. I started out with space, with satellites,
Yeah.
and that in that framework of using satellites and modeling their orbits, that is actually the work that I like most. Looking back, that
Mm,
I'm most happy about. Although it hasn't gotten me the what's it called, the large appreciation in the sense of peer review and what's it called, is these points that you get for having many people refer your publication as H index and so on.
ah,
Yeah, okay. But so actually, the writings that I most like are not the writings that the rest of the world most likes.
yeah, yeah,
That's
yeah.
just how it is.
What is your advice to us as younger or to a generation younger than me?
That's actually a good question of which I don't have a real answer. I've noticed I'm still meeting young people in research and in education, in academic environment, doing geodesy or subjects related to geodesy like photogrammetry or GIS, spatial information systems, and so on. And both here in Finland and internationally. And I must say that they're so much smarter than I. They know so much better what they should do, and I would say just do it.
I see a challenge in the world that is the contribution or the subject of geodesy is getting less now and getting less and less. And this is actually the idea that we should, the idea to promote this subject itself for the next generation.
Yes.
Geodesy should
Mhm.
exist first. Then
Yes,
we
under
can
its own
train
name.
next. Yeah, exactly, exactly. Mhm.
No,
So
I agree. It should exist under its own name, and we should point out when people are doing geodesy, whenever whatever they are, if they are space people building satellites, or they are people involved with land parcels and such, registration of boundaries of land parcels, or aerial photography by drones, whatever they do, if it has to do with location in space
yeah,
around
yeah.
the Earth, then it's geodesy.
What do you think about 10 years, 20 years? We will be? But its status will be in the future.
Yeah, actually, of course, more of the same. But you probably mean what surprises will we see? What didn't we expect coming? And I think there's one surprise that I have been waiting for already for a long time, and that is I hope that finally we'll see relativistic geodesy and especially relativistic leveling make its breakthrough. And I'm
Mm,
hopeful that it will. Quantum sensors are coming also. That's another
yeah,
thing. But I expect that the big thing will be, and I would say that in 10 years, I hope in 10 years that uh, we will have uh, a precise global vertical reference system based on atomic clocks.
yeah,
And I'm
yeah.
hopeful that will happen.
That's
And
yeah.
that
That's
means basically that eliminates, it doesn't eliminate, but it's an additional technique to get an absolute vertical reference in addition to the
mhm,
technique that we use
mhm.
now, which is a precise geoid combined
Yes,
uh,
yes,
with GPS positioning. Yes, that is a good technique, but
yeah,
it's
yeah.
not robust compared to the relativistic technique.
Okay, so,
If we
yeah,
can get those clocks to be precise enough,
yeah, 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 yeah. Yeah.
so that's my
So,
hope.
what should we do, Martin? What should we do so that the policy makers or these decision makers can pay more attention to us on our subjects? What is your
Well,
idea?
we
What should
need to
we
be
do?
we need to be active in our outreach also to the public, not just to politicians, but to the public, because
Mm,
politicians listen to the public. And
Okay.
I think one community that geodesists could take an example of is the community of climate scientists.
Mm,
Their position, their outreach position, and their understanding in the public eye, also by politicians, has been very challenging. And they've learned a lot. And they're very good at it nowadays. I know a number of them, and they're really good at doing outreach and explaining to the public the things about their science. And geodesists should do the same. Although our position is not quite as challenging because people accept that geodesy exists. They don't question that.
tell us very short about geodesy based on your experiences during years. Yeah,
It
exactly.
includes it
Everything. Yeah.
includes everything in the study of the Earth and perhaps other planets too soon. Uh, Everything in the study of the Earth where geometry is decisive, where things are precise geometry, where things are precisely. Whenever
Mm,
spatial location is involved at the high level of precision, we're talking geodesy.
exactly. Actually make jokes with colleagues. They say that what is your role? I say that we are everywhere and nowhere. And nobody
Yeah.
sees us, but we are
Mhm.
everywhere.
Yeah. You know, geodesy is as a science, geodesy is an infrastructure. And
Yeah,
I've sometimes defined infrastructure as the thing that you don't realize is there until it stops functioning. Then you realize it's there. Geodesy is a bit the same.
exactly. Exactly. So thank you very much, Martin, for sharing your experiences with us and participating in this interview. You know that this interview will be published on YouTube and my channel,
Yes,
Digital
I know. Yes.
Geodesy
Well, I
Digital
hope you can
Academy.
make
Is
something.
it okay?
Yeah. Yes,
Yeah.
it's fine. I hope you can make something of this video.